show that the following points are collinear. A is at 1, -1, B is at 6, 9, and C is at 3, 3. So for 3 points to be collinear, collinear means they all lie on the same straight line. But so if I draw a little sketch, hopefully we'll see what we need to do. And in fact, they're quite simple points. So if we start with A, so say A's here, and we know A's at 1, -1. B goes all the way to 6, 9, and C's at 3, 3, which is kind of in between this. So if I put kind of C and then go to B, something like that. That's probably not bad there. You don't need to draw a sketch, but I'm going to do it for one of them, just because hopefully it will help. But the actual principle, it doesn't matter if your sketch is any good or not for many, many questions. So C is at 3, 3, and B is at 6, 9, right? So for these to be collinear, you need the gradients between any 2 points need to be equal. So basically the gradient, I'm going to call gradient M. M AC would be equal to M, so that was AC, would be equal to MBC, which should also be equal to MAB. So say I took the 2 short lines, if it was MAC and CB, if they were equal, there's 2 gradients, that means they're parallel, and if they've got this point in common, e.g. point C, because they both AC goes to C and CB goes to C as well, because they are parallel lines, e.g. same gradient, and they have a point in common, that means they're collinear. So it doesn't matter which lines I pick. I don't need to do all 3. We could just prove it by picking any 2. So we could pick AB, the whole line, and then just AC, and again they've got this point A in common. It really doesn't matter. So I reckon I'm going to pick AC and BC, but like I say, it is your choice. So MAC, gradient of AC, remember the gradient formula, M equals y2 minus y1 over x2 minus x1. So for MAC, I'm going to pick A as x1, y1, and C as x2, y2. So it's going to be y2, 3, minus y1, minus 1. So that would be 3 minus 1 over x2, 3 minus x1, 1. 3 minus 1. So 3 minus 1 is 3 plus 1, which is 4. 3 minus 1 is 2. 4 over 2 is 2. So the gradient of the line from A to C, the straight line, is 2. So now I'm going to do CB, M of CB equals, I'm now going to call B x2, y2, and C x1, y1. So it equals y2, 9 minus y1, 3. 9 minus 3 over 6 minus 3. 9 minus 3 is 6, 6 minus 3 is 3, 6 over 3 is 2. So that means MAC equals MCB. So that tells us that the lines are parallel. AC and CB are parallel. So that's sort of half of the story. The collinear bit comes from this common point. So I can say A, B, and C, the points, are collinear because, so I've already shown that they're parallel because AC and BC or CB have common point C, or meet at point C, have a common point. So the same gradient bit means that they are parallel, as in they could be something like this, but the fact that they both pass through a common point, they must be collinear, one straight line going through them all.